Example 4a, find the optimal minimal allocation for the following. So on the left, I'm going to use common sense and just looking at the numbers. And then on the right, I'm going to do the Hungarian algorithm. So in this example, I used a spreadsheet to do the row reduction and the column reduction. And so therefore I could just replace the numbers with whichever was the smallest in the end. Once you set up a spreadsheet, this could be very useful because once you have done for one 4x4 matrix, you've done them for every 4x4 matrix, and it will automatically calculate it for you. Let's have a look at example 5a. Example 5a. The matrix represents the number of jobs of hours taken by 4 people to complete the 4 jobs. How should the jobs be distributed? Once again, I'm going to use just looking at the table to help me out. And then on example 5b, I'm going to show using the Hungarian algorithm. Doing this method is showing that Jocelyn is not highlighted for any of these jobs. Amari could either do job 1 or job 3 in the smallest amount of time. Which one should we go with? Well, whichever one we don't go with is the one that we have to assign to Jocelyn. So with job 1, Jocelyn would take 8 hours, but with job 3, Jocelyn would only take 6 hours. So therefore, we should give Amari the job that would result in Jocelyn having the least amount of time. So 6 hours, we'll get her to do, Jocelyn will do job 3, which will take her 6 hours, and Amari will do job 1, which will take her 4 hours. We can see doing the Hungarian algorithm that we have only ended up with 3 lines. So now we'll need to go and create some more lines. We now have 4 lines, so now we can go and allocate accordingly. Now example 6 is a little bit different, it's a bit of a tricky one. The following shows the scores out of 10 for each employee received for completing a job. Who should do each job? So if it's a score out of 10, you'd want the people that have got the highest scores to get this one. So we have to do a reverse or do a slightly different Hungarian algorithm. But let's start with the logical path. So we've solved this question just by looking at who got the best scores. We didn't even have to compare, which is great. So with the Hungarian algorithm, we're going to have to do something slightly different. With this one, because if we do any subtractions to try to find the largest number, we're going to get negative numbers, which we cannot have. So what we're going to do is we're going to do one small alteration. The first alteration is we're going to take whatever is the biggest number in the matrix, in this case 9, and we're going to do 9 take away each of the other numbers. Once we've done that, then we can do the normal row reduction and column reduction that we all know and love. And there's you doing the Hungarian algorithm when I want to find the largest numbers.